Let's now have a look at our trig functions. We've done a lot of trig, of course, but the one thing we haven't done yet is to see how we use calculus with trig. So let's work out how to differentiate trig. In order to do this, I need to look at some limits. If you think of your sine curve, we know that as x approaches 0, well, sine is going towards the origin, we know that. Cosine would be going towards 1, and just to complete it there, tan would be going to 0. Let me draw in a circle. Now, again, I'm going to use the idea of trapping areas here, but this time on the circle. So we have sector OAC, radius of my circle is 1, x is in radians, so I'm saying that's x radians at the centre. Now, if I was to draw that triangle in, the area of that triangle clearly is less than the area of the sector. If I was to draw a tangent in and create a right angled triangle, that area would be bigger than the area of the sector, and I can use trig to show that, well, the length of AB must be the value of whatever tan x is. Okay, so area of a triangle, half base times height, and so the halves are all going to cancel, the ones will obviously cancel, and we're left with x is in between sine x and tan x. Well, if I divide everything by sine x, okay, sine x on sine x is less than x on sine x is less than tan x on sine x. Well, sine x on sine x is obviously 1, and tan x on sine x is 1 on cos x. But if I look at that as x approaches 0, and we said the limit for cos x, that would be 1. So now the right-hand side of this inequality is also 1. So we know that as x is approaching 0, x on sine x, we've just trapped it between 1 and 1. So it's fair enough to say the limit as x approaches 0 of x on sine x is 1. It's also what's known as the small angle theorem. So for small angles, x approaches 0, x is actually equal to sine x. It's another way of saying that, because x over sine x is 1. So for smaller angles. So first of all, before we talk about the calculus, let's talk about these type of limit questions we might get. The key is, what we know about this limit is the algebra, or on the numerator or denominator, in this case it's on the numerator, must match the angle. And in this case it does. So as long as it does that, we know that this will be 1, the limit is 1. Right? Because if x approaches 0, 5x must approach 0. But if I get x on sine 3x, I have to play around with it. The algebra in the numerator in this case has to be 3x. So I can go a third times 3x. Well, the 3x on sine 3x we know is 1. So therefore that limit must be a third. All right, y equals sine x. The only way I'm going to differentiate this at this stage, because we don't know how it works, is by first principles. So I'm going to do function x plus h minus function x all over h. We shall expand out our sine x plus h. You get sine cos cos sine. And now I'm going to break this up into two pieces. I've got cos x times sine h on h. The reason I've done that is because I know that limit is going to be 1. So I've got cos x. Then I've got sine x times cos h minus 1 on h. I'm going to have to play around with that one. Cos h, I'm going to use my double angle theorem. I'm going to change to 2 cos squared h on 2 minus 1, but then minus the other one that's on there, it becomes minus 2. Now, if I rewrite that, cos squared minus 1 is minus sine squared. So cos squared minus 1 would be minus sine squared. So I now have 2 sine squared h on 2 on h. But now I'm going to break that up to be sine h on 2 on h on 2 times sine h on 2. Because now, you'll notice in my fraction, the angle is the same, in this case, the denominator. So I know that that fraction, as h approaches 0, that'll approach 1. The sine h on 2, that's sine 0, it's approaching 0. My first one, sine h on h, approaches 1. The sine h on 2 and h on 2 approaches 1. And the sine h on 2 approaches 0. So we end up with cos x times 1 plus sine x times 0, cos x. And so there's our proof that the derivative of sine x is indeed cos x. To generalize it, if we have the sine of any function, we differentiate the angle, and then it becomes cos of that angle. The angle doesn't change. And remember, all of this is in radians. Has to be in radians for this to work, because you go back to the original circle where we proved that limit. X was in radians. Okay, y equals cos x. Well, now we know how to differentiate sine x, we can do cos x, because I can rewrite cos x in its complementary form, sine of pi on 2 minus x. And we now know that we differentiate the angle, that'll be -1, and sine will change to cosine, the angle doesn't change. But now I'll say, well, cosine of pi on 2 minus x, the complement of cosine is sine, so cosine goes to negative sine. So to generalize that one, if we've got cosine of some function, we get minus the derivative times the sine of function x. Okay, well, let's do tan. Tan I can rewrite as sine and cos, and I now know how to differentiate both of those. So we shall square the bottom, cos squared. Write down the bottom, cos x, diff the top, differentiate sine, we get cos. Minus, write down the top, sine x, differentiate the bottom, differentiate cos, I get minus sine x. So on the top, I now have cos squared plus sine squared, which we know is 1. And so 1 on cos squared would be sec squared. So if we differentiate tan, we get sec squared. To generalize that one, tan of function x, the derivative becomes the derivative times sec squared of the angle. All right, so let's do some examples. We have y of sine x cubed. We said differentiate the angle, 3x squared, sine goes to cos, the angle doesn't change. So 3x squared cos x cubed. Tan of 1 on x, differentiate the angle, differentiate 1 on x, we get minus 1 on x squared. Tan goes to sec squared, the angle doesn't change, so 1 on x. Oh, let's combine a log. So the log of cos x, it's a log function, so we go derivative on function. The function is cos x, the derivative of cos is minus sine x, so I get minus sine on cos. Hang on, sine on cos, that's tan. So we get minus tan x. 10 to the power 5, anarchy. Bring down the power, 5, lower the power, 4. Diff the inside is tan x. Differentiate tan x, you get sec squared x. Cosine of e to the power of x, differentiate the angle, e to the power of x, differentiate it, we get e to the power of x. Cosine goes to minus sine, and so we end up with sine e to the x. That's our questions to do.